Here we have a Nintendo Switch that came in for no power. The console is charging at 15 volts, 0.48 amps. Or on this mechanic charging station, it's showing 12 volts at 0.6 amps. A normal good working Nintendo Switch should start with 12 volts, 0.6 amps, and then it will switch to 9 volts and then higher amperage, maybe 1 amp or 1.3 amps or 1.5 amps. So right now the switch is stuck at 0.6 amps, 12 volts. And if we measure it on the 15 volt charger, it's stuck at 15 volts, 0.48 amps. So right now the console is not powering on. Let's do a quick visual inspection and see if we see anything obvious. Oh, this area does not look good. Look at the cap here. Let's continue with visual inspection. And right now I do not see anything obvious other than the area down here. Flip the board. And back of the board looks good. Now we're gonna do some measurements because visual inspection alone is not enough. Sometimes it's enough, but in this case we need more information. Meter in diode mode. Look at this, we have a short here. Okay, so we have a short. This one is good, but this one is not good. If we measure in ohms mode, what do we get? In ohms mode, I'm getting 42 ohms. Thank you, Miguel. Thank you, man.
I gave you your 2 back.
Right now, I'm reading 42 ohms. But voltage drop is 0. We should get around 0.4 voltage drop, but we are getting 0. So we know that we have a problem. And from experience, I know that this cap is linked with this. I've had this issue before where we had a short on this capacitor and it turned out to be this area here. So I was right about this area, not looking good. Let's measure our M92. And we don't have a short. And we're gonna quickly go over this fuse here and we're good. Quickly take a look at P13 on the back and it should be good because the M92 caps on the side, they measured good, so most likely we're okay here. And we're good. And now we're gonna work on this area. That's what I think the problem is. We do not have a short, and we do have a short here. So we only have a short on those 2 caps here. And a short down here, so 1, 2, 3. The short may be coming from any one of those 2 caps or the one on the bottom, or it's very possible the problem is the chip itself. How would we know? We can start by removing the caps and see if we can get rid of the short. I think that would be the easiest way. If not, then we'll just remove the chip, replace it, and hope for the best. But before I do this, let me inspect the board under a thermal camera. I just want to see if we see anything obvious under the thermal cam. So I'm going to plug the battery like this. Right now I do not have the charging cable plugged in. We only have the battery plugged in. And look at this. We see a heat spot at this area that does not look good, where we had 3 shorted caps. And if we plug the charging cable, the same. We have a heat spot here. So that confirms that we have a problem on this area of the board. Now, a nice feature on the floor cam is since I do not have a macro lens for the floor cam, and I do not have any of the UNI-T thermal cams in stock right now, let's try to use the zoom feature. It's a digital zoom, and see if we can figure out where heat is coming from. All right, and look at this. I think the cap under the chip is what's causing the problem. Okay, so I have my tweezer on that area, and let's take a look. Yeah, I think the problem is coming from the cap, from this bottom one. Let's unplug the battery because the board is super hot right now because of that short. I honestly highly doubt that that tiny cap is going to cause the board to heat up like this. I can feel the heat on the board. But right now we see the most heat on this cap on the bottom. I mean, we have a couple of options. The bottom cap, the top 2 caps, or the chip. One of the 4. We're going to have to get rid of the bottom cap anyway because it does not look good. But before I do so, we need to cover up that plastic part right here. That plastic part is very close to the chip and to the parts. Right now we're going to be using the pre-cut thermal pads. We got those last week and the product is already posted on our site. And there are a lot of pre-cut thermal pads in there. What we can do is we can place a thermal pad over that connector to protect it. The pad comes with a pre-applied plastic wrap on the top and bottom, so we have to make sure to remove those plastic wraps. And let's place that thermal pad over that connector. And that thermal pad is thick. Look at the thickness on that thermal pad. So we just covered that connector. The size of each pad is 12 by 12 by 1.5 millimeters and 100 pieces per jar. Let's see how that will work. We can even give more protection if we put a metal shield like this. That would be the safest way to go at it, but the thermal pad alone should be enough. And let's see, do we still have a short? Do we still have a short here? Oh, the short is gone. Whoa. The short is gone. That's amazing. Hopefully that fixes the problem. I mean, honestly, I was aiming more towards replacing the chip, but it looks like that tiny capacitor did it. And we're gonna grab that capacitor from a donor board. Let's remove the shield and the thermal pad, and look at our connector, intact. I love those pre-cut thermal pads. Ever since we got them last week, I've been using them every day, and they work. They work. I love the fact that they are thick. And right now all we have to do is test and see if our charging station will jump from 12 to 9 volts. If yes, then the problem is fixed. 12 volts, 0.6 amps. Ta-da! 9 volts at 1 amp. Done. Fixed. I'm going to give it to Big Boss to reassemble and test, and I'll be back to finish the video. I'm back. Big Boss reassembled the game console. We're going to press on the power button, and ta-da! Console is working. That's it. We're going to invoice and mail this back to the customer. I hope you enjoyed the video. Don't forget to like and subscribe. Leave a comment if you have any questions, and we'll do something else in the next video.